Okay, so in this recording, we're going to continue our techniques for integrating trig functions. In the previous video, I looked at secant tangent functions, but my recording cut out. I don't even know if it's saved. It's trying to render right now. So hopefully I don't have to re-record that. But in that video, we looked at integrating products of secant and tangent whenever secant has an even exponent. Okay. And the goal, again, always with these trig techniques is that we want to somehow algebraically manipulate the expressions so that we have a function and its derivative right next to it. So here, in this case, we're going to look at instances where the exponent of tangent is odd. We're going to break this guy up into this form, and then we'll be able to see that, oh, we have a bunch of secants here, right? We have a bunch of secants, and then we have secant tangent dx. The derivative of secant is secant tangent. So this is what we're saving. This is our goal to get on the side. We want this, and then we want some power of secant on this side. Okay? So we have odd exponent here, odd positive exponent for tangent. So let's do this one. And remember that the formulas can be a little intimidating. Just remember the goal. The goal is to split this thing in half, and you want something that you can write as u over here, and then something over here you can write as du. That's the goal. If you remember that goal, you'll have a much easier time with these formulas. In fact, I don't even look at those formulas when I do these because I know the goal is to just split it. Okay? So I can't emphasize this enough. Don't get bogged down in how messy this is. Just split it into u and du the best you can using this identity and mainly that identity. Okay, so that's the goal. Let's see if we can get there. So first off, I'm going to write this as a product by bringing secant up and writing its exponent out. So let's be secant to the power minus 1/2 dx. So now I want to somehow I want this, right? I want secant tangent dx over here. And I don't see secant by its, I can get a tangent out, right? I can write this integral as tan squared times secant to the power minus 1/2 x, and then I'm going to put a space right here, which will become apparent why in a moment, but all of this times maybe be careful in the space I have, tan x dx. So I see tangent squared. That's good because I can rewrite tangent squared as secant squared minus 1, but I still need a secant to put over here a tangent. Well, I'm always allowed to multiply equations by 1 and not change anything. So what about if I multiply by secant right here? So what if I multiply by secant right there, and then I have secant tangent, but I changed it. What I need to do is multiply by a fancy version of 1. Like that. That's equal to 1. Nothing's changed. But now I can just simply choose where to divide this secant x out on. So I'm going to choose to divide it from that one. And I'm going to rewrite the tangent squared. So I'm going to divide secant into there, and I'm going to rewrite tangent squared x as secant squared minus 1. Because I know my goal. My goal is to get a bunch of secants and then secant tangent over there. So this will be secant squared minus 1 for there. And then this is going to be secant to the power minus, so minus 1/2 minus 1 is minus 3/2. So secant to the power minus 3/2. And then I have my secant x tangent x right there. And that's my du right there. That's what I want over there. So now I just gotta send everything in here. So all of that times that minus all of that times that, separate the integral and see what I get. So I'm gonna write this as two integrals. So I'm gonna take that secant and multiply that thing. So what is that? So 2 minus a half, what is that? That's gonna be 8 over 2. No. What am I doing? 2 minus 3 halves, why can't I think? That's just 4 minus 3 over 2. Oh, it's just a half. Oh, I'm down, it's 3 halves. Why didn't I even see that? So that'll be, that secant times that secant will be secant a half x. And then I have all of this junk. Secant x tangent x dx minus this integral here. So can I fit that? Minus, yeah, I think it can fit. Secant to the power minus 3 halves times secant tangent secant x tangent x dx. Perfect. So now this is that's my du right there. And then my u is right here. So it's a u to the power 1/2. Yeah. And then minus, and then this is like my u here. So it's a u to the power minus 3 halves. And then there's my du right there. So if u is equal to secant squared, if u is equal to secant x, I'm sorry, and du is secant x tangent x. So now it's just a matter of integrating that. So what is that? Add 1, so 3 halves. Yeah. So it'd be 3 halves would be 2/3 of u to the power 3 halves. But what's u? U is really secant. This one minus add 1 and divide. So I add 1 to that. What is that? So why am I having such a hard time with fractions right now? 2 over 2. So negative 1/2. And then divide by that, it becomes positive. Positive 2 secant to the power minus 1/2 x. And then don't forget your integration constant c. Make sure I did that one right. Yeah. Yeah, that's it. Those are super easy ones. But again, you just have to remember the whole goal of all of these, including the ones with cosine and sine, it's just to get, just break it up into only something and its derivative next to it. It really doesn't even need to be its own. You don't even really need these formulas that they give you. If you just remember that u substitution relies on u and its derivative, and if you remember these identities, then you should be able to get there. There's only one exception to this philosophy, though, and that's when neither tangent has an odd exponent, nor does secant have an even exponent, positive, both of them being positive. When you don't have neither of these, then you have to do something. You have to use integration by parts for one more case. In fact, I'm just going to pause the video and write that case up, and then I'll restart it. Okay, so it turns out that the recording that I thought was good, that cut out on me, that I thought what might have been savable, it turns out that recording did not render well. It's very choppy, very annoying. So I have to do the problem again. Still, we're back on secant and tangent trig integration. And in this instance, we're looking at products of secant and tangent where secant has an even and positive exponent. Why do I have odd? And it should say has a positive even exponent. That's what it should say. So secant, when it has a positive even exponent, even being 2 times an integer. When we have this instance, we're going to have the goal be to partition the integral into tangent pieces algebraically and secant squared. And the reason for that is that I don't care what type of power we have of tangent, if we can get right tangent as the power on its own and secant squared is over here with dx, tangent u is secant squared, the derivative of tangent u is secant squared du dx. So the derivative of tangent is over here. So again, we're like partitioning algebraically, we're factoring, playing around the best we can to get u du. Okay? So here actually, this shouldn't be too bad. There's an even exponent, even positive exponent for secant. So I'm going to go ahead and start partitioning into what? I want a secant squared. And again, as I said before I paused the video, I don't even think about these formulas. I just know what I want. I want the derivative of tangent over there with dx. So I'm going to take a secant squared out of this guy. So I'm going to have secant squared 3x times tangent of 3x, so tangent cubed of 3x times secant squared x dx. So I'm already got it over there. Now I just got to use identities and factoring and whatever I can to just make that into a bunch of tangents, which I can. Secant squared is equal to tangent squared plus 1, using that old Pythagorean identity. So I can write that out. Tangent 3x. Okay, and tangent cubed 3x. And then secant squared x dx. Now I'm going to distribute this in, and I'm going to write this as almost messed up. That should be 3x. That should be 3x in there. I'm going to distribute it in. I'm going to write it immediately as 2 integrals. So we're going to say, okay, this will be that's going to be tangent 5, tangent to the power 5 3x, secant squared 3x dx plus that times 1, so that's not too bad. Cannot forget those 3x. I was rushing. I already did this problem, and I just want to get it over with, but you gotta be careful. Don't rush and forget that there is a u now. There's not just x. And that u is 3x, which means that du is equal to 3 dx, which means that du over 3 is equal to dx. So now I have u to the power 5, and a tangent of u. No, that's not my u. That is definitely not my u. The whole point is to have the derivative of this thing for that thing. My u is tangent 3x. So then my du is going to be equal to derivative of the outside times the derivative of the inside. It's going to be 3 secant squared 3x dx. which means that du over 3 is equal to secant squared 3x dx. Perfect. So now I need to associate with each of these. So this right here is du over 3. That's du over 3. So I can just take the third out from each of those. So 1/3 integral of u to the power of 5 and then du. Plus 1/3 u to the power of 3. So the integral will be to the power of 3 du. You know, this is a simple integral. This is 1/18. Making sure I didn't do anything wrong. 1/18 of u to the power of 6, but u is really tangent 3x is the tangent to the power of 6, 3x plus 1/12 tangent to the power of 4, 3x plus c. Don't ever forget that integration constant. Let me make sure that's correct. Tangent to the power of 4, 3x. Yeah, that's it. Again, I immediately saw that when I chose u to be 3x, I was like, what am I doing? Because when I looked at du, I was like, oh, there's a whole function over here, 3 secant, right? So again, it's okay to make mistakes. Just know where you're going so you can like pick up where you can look to where your mistakes are. And since these were the two main topics for the product of secant and tangent, so when you have a positive even power for secant or an odd positive power for tangent, these are the two methods that you can use to integrate these terms. And again, it's all about u du separation. I will make another short video for looking at tangent, powers of tangent and powers of secant on their own. And that will be it for this video.